Hi guys, we're going to go over a script that I recently wrote, recently modified it, that will go ahead and scrape websites, particularly journal websites. And the modification that I did is to download PDF files from those journal websites and then put them into a designated folder. So what are you looking at here? This is our R script that you'll be using. This is one that I wrote. The first thing that you want to notice on it, and the first thing that you want to do is setting your working drive. So this is set WD. What this does is create a folder where all your R files will go. Mine is here in the D drive. You can see it here. See, here's my folder. And then here is all my R folders associated with it. I've also annotated this script. The annotation isn't nearly as detailed as this video, but it'll kind of help you get along with it. The next script is one that I like a lot. I use it in pretty much all my scripts, and you're free to use it wherever, which you can load all your packages automatically rather than having a line for each. The nice thing about this script is that it checks if you don't have a package installed. So in this case, if you don't have any of these packages, stat check, rvest, xml, per, dplyr, or stringr, it'll install. It checks to see if you have them loaded, and if you don't, it installs them. One difference with this is sometimes people use require and other times people use library. I use library. You can use require if you have two competing packages with like the same name, and then you can use what require will do is mean where one function will supersede over the next, but that's not important in this case. The next step on here, this is our scraping function. You don't want to mess with this. Like for using this script, you don't want to mess with these two portions. These are self-contained. So this script, pretty much what it will do is get all the URL links from an HTML, from a website. So leave this one here alone. The next thing is what you will be doing a lot of changing with, which is our journal pages. Each of these lines corresponds to one issue of a journal. So this is GCQ, and these correspond to actual websites. So if I go here, and I'm going to go to, okay, whatever. PA, let's go here. This corresponds to an actual journal page. So what are we trying to get from this journal page? We are trying to get these here, these great links. If I control U, this is what we're scraping. And we're trying to find the links located in here, these things right here. Oh, those are scripts. Let's see. I'll try PDF. So we're trying to get our links that are embedded within this HTML script. So each of these will correspond to a journal issue. So what you need to do when you're working with this code is change these. You need to go to the journal website that you want to scrape. So let's say I don't want to scrape Gifted Child Quarterly. Let's say I want to scrape Journal Advanced Academics. I think I know that one. Or let's go away. Right, 1-1, because I don't know the whole issue number. I'll do it this way. This is much easier to do it this way. So what you really need to know is what's JOA. So I'm going to go to all issues here at the journal website. And let's see what their naming convention is. So let's check here for this one. Usually most journal naming conventions is the volume, issue. It's the journal shorthand, its initials, the volume, issue. This across SagePub is always the same. And so across editors, they will always have this first part will always be the same. So you don't necessarily have to change that. What you do have to change are these portions, which is the journal initials, the volume and the issue. So you can see this starts at journal issue 63. This is out of order. I went backwards from 63 to 59. I forgot to put 64 in there. Started 64, which I did. And then I went all the way backwards. So this goes from 64 to 54. So we have that. And all you want to replace is, so if we were to replace here, let's say if we wanted to JOAA, I would see, I would go to here and say, oh, okay. Right here, I'd copy this and I would just paste it right here, just like that. And then I usually don't change these because most journals do 1, 2, 3, 4, but you have to check. So it's important that you check through just to kind of glance through, because some journals will go to 3 issues and some will go to 6 issues. So that's one thing that requires a little bit of man hours, is just checking to make sure that this catches all the journal issues. The next part of the script is this portion. While we're doing this portion, so let's run this. This will take a little bit. I'm only going to run page 1 and page 2. I'm only going to run the first 2, just to do things quick. So let's look and see what that gives us. Let's look at page 1. It gives us everything. We get a bunch of junk, which we don't need. We also get things we do need, like DOI full and DOI PDF. These are like the gold nuggets that we are after. This right here. But amidst all that, there's a few gold nuggets and about 200 lines of junk. We don't want any of that junk. So then we're going to go ahead and we're going to change. So let's look at this again. So its column title is currently nothing. It's not very useful. So let's go ahead and change that. Its column header is now scrape. So that's all this does. It adds a column header. And column headers are useful in R because then you can kind of talk about them. R is an object-oriented language. So you need an object is like a label. So pretty much what I need to do is to manipulate that column, I need to give it a label, aka a header. So then I put them all together here. That's what this does. So each of these, like you saw, is its own little data set. So I need to put them together. And that's what this does. It binds the rows, which means it stacks the rows on top of each other. And I get this. So now I have my 2 pages. Base. And before I had 195 rows. Now I added my second other page that I scraped, my other issue. I still have a lot of junk. I have 426, more than doubled it. So each of these from GCQ is about 200 rows. We now need to get rid of all this junk. So our next step is to do that. So there are 2 scripts here. The first one is focused on getting all the HTML version of the articles. The second one is to get the PDFs. The PDFs and to get those URLs are good if you want to download them, which is what we'll be doing here. So what does this do? This script says, okay, I want to find only those rows that contain DOI, this string right here, /DOI/full. Because when we look over here, let's look again. Oops. Some of these rows have junk we don't care about. But the rows we do care about have, let's see if I can find one. Junk. This. So /DO, I want the rows that only contain this, like row 155. So what I'm going to do is I'm going to say that this string, I'm going to call it P1. And I'm going to say my big set GCQ base, only pull out the rows that have this string in them. I'm going to call that data. So let's view our data now. What do we have after we brand that? Did I forget to do P1? Let's try that again. So now I only have our data set is a little bit smaller now. Instead of 195 rows or over 400, it's now 18. We've got all the articles with full, but this doesn't help us yet because this isn't a full URL link. It stops, so we have to complete the URL link. So I know this is one thing that you might have to change given the article website. For SagePub, all of their HTML articles have this at the beginning of them. HTTPS ://journals.sagepub.com, every single one. So we need to add that to each of the journals. So I'm going to go ahead and do that. Again, I'm creating an object, a label for this string, and I'm going to add that label to each one of my strings. And let's look at what I have now. So now I have a new object called URL. Let's see what that looks like. There we go. And now we have the full links to where the HTML text is. But if you want to download them, you need these to be PDF. So we're going to do the same thing. This script is the exact same as the other one, except it looks for lines that contain the PDF link. So then I'm going to view. So let's see what we have now. We have the PDFs. Now this is a smaller link. And the reason is, if you're doing this at home, I don't have access to all the PDFs because I'm using my home network. Usually to get these PDFs, you need to be on a university network or a library network that has access to them. So I have access to all the HTML, but I don't have access to all the PDFs. Thank you, Sage. You know, very generous. So in this case, I only have 9. I have half of them. That's okay though. It's good for this. So I have all the links. Now the next step is we want to download those. Downloading those one at a time is a pain in the neck. So instead of doing it that way, we're going to write a script to do it, which is what I did. The first thing we need to do is figure out where we want all those PDFs to go. So for me, I created a drive in my C drive called GCQ. Right here. This is what I know. So you need to make a folder wherever you want. For me, I did in my C drive. For me, I labeled it GCQ. So now we have a file location, which is C:/GCQ. Note for R, one thing is R/ is always this way. So even though Windows has it going this way, for R, you need to change it to the other way. So I'm going to tell them for all these names, I'm going to create a new data set, which is called destinations. And the destination is where the file path for each of those PDFs. And so let's do this. Let's see what we have. That's the first thing. So I'm changing this, the HTTPS, to the file location. So if I look at destinations, all right, this actually looks like a URL, but I'm missing something very important for PDFs. For all files, you need a file type. This has no file type. It needs a .pdf. So the last thing that I'm going to do is I'm going to paste .pdf to the end of each of those file paths. So let's go ahead and do that. And this one is called destination. I just dropped the S. I changed the label a little bit, but I want the labels to be the same. That's my naming convention. You could have the labels like this thing, the label be whatever you want. But for me, that's what helps me organize it a little better. Now these look like file paths. So this is .pdf, perfect. Now, once I have this, I run my final script, which is I sequence them, which is a simple for loop. So this says for all articles, all I in the sequence. So for each row in this column, PDF articles, I want to download the file from that URL, and I want to put it in the destination along that row. So for destination here that I designated here, so that corresponds row to row to row. This you don't have to worry about. Don't change this. This is just like the kind of format. So don't worry about that. To be very honest, I don't have the good technical background to tell you all the difference between the types of bits, downloaded types for files. So I'm not messing with that. So this gives you a whole idea of using this script. This will probably seem like a whole lot at once since it's a lot of script, but you really see that it's very manageable pieces. For me, and very intuitive. Here you just correspond to the URL. Here we're just adding a label, a header to each of those data sets. Here we're putting them all together. This is my minor one, so I'm going to take this one out. You don't need that one for what you're doing. That was just for my example. The next portion just subsets it, gets a smaller data set looking for only data in particular rows. And finally, we just tell where we want those PDFs. If we're downloading PDFs, we're telling them where we want to go. I hope you found this pretty helpful. If you have any questions, just go ahead and send me an email or ask me during our weekly meetings.